their number of elements are nothing but the same. For example, in P cross Q also you can see there are two ordered pairs, and Q cross P also you can see there are two ordered pairs, but they are not equal. What are the elements only in A cross B? All the three elements, because they are not repeated in A cross C. So obviously that is A comma D, B comma D and C comma D. We should always take the domain element from the set A. So we have a relation y is equal to 2x plus 1. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Here in this session, we are going to study about the Cartesian product and the relations of sets. Before moving to the Cartesian product, we need to understand about the ordered pairs. So what do you mean by ordered pairs? So let A belongs to set A and B belongs to set B. Then the ordered pair of elements A and B is denoted by A comma B inside the common bracket. A is the first element, B is the second element, which means, so let A belongs to the set A and B belongs to the set B. Then we pair two elements where A belongs to the first set and B belongs to the second set. So A is the first element which belongs to the first set and B is the second element which belongs to the second set. For example, let A contains the set 1, 2. 1, 2 are the elements in A and let B be the elements which contains A. So when you want to pair this, so 1, A. So 1, A and one more pair we can create, that is 2, A. So pairing elements with the two sets is nothing but the ordered pairs here. Here always remember the first element belongs to the first set and the second element belongs to the second set. So this is called as the ordered pair. Now equality of ordered pairs. So when we say that two ordered pairs are equal, when the first element is equal to the first element and the second element is equal to the second element. For example, what is the value of x comma y? When it is equal to the ordered pair 2, 4. I clearly said, so always first element is equal to the first. So therefore, the value of x is equal to 2 here and the value of y is equal to 4. So this is nothing but the equality of ordered pairs. Next is the Cartesian product. So Cartesian product of two sets A and B is denoted by A cross B, is the set of all ordered pairs in the form of A comma B for all A belongs to the first set and B belongs to the second set. For example, I have taken set A here, A comma B, and set B as C, D, E. Then A cross B is defined as A comma C, A comma D, A comma E. A comma C, A comma D, A comma E. Similarly, next we will pair with B comma C, B comma D and B comma E. So collection of all these ordered pairs with respect to the sets A and B is called as the Cartesian product. Now let me take one more example. Let me consider set P is equal to L and M and set Q is equal to R. Now P cross Q is nothing but L comma R and M comma R. We'll pair each elements of set P with the elements of Q. Similarly, we can also define Q cross P. So when you say Q cross P, you need to pair the elements of Q with respect to P. So we will get here R comma L and R comma M. So from these two sets, we can clearly see L belongs to P and R belongs to Q here. Similarly, when I say Q cross P, the first element R belongs to Q and L belongs to P. But clearly observe here, none of the ordered pairs are equal in P cross Q or Q cross P because L comma R is not equal to R comma L. So we can say that the Cartesian product P cross Q cannot be equal to Q cross P. That means they are not commutative. So their number of elements are nothing but the same. For example, in P cross Q also you can see there are two ordered pairs and Q cross P also you can see there are two ordered pairs, but they are not equal. Now, what happens if one of the set becomes empty? Now, if A is empty or B is empty, so there is no elements to pair the and write in the form of an ordered pair. So therefore, A cross B will be an empty set. Now, if A is non-empty and B is non-empty, obviously A cross B is a non-empty set. Next, if A cross B is empty, if and only if either A is empty or B is empty. So if A cross B is empty, that means either set A is empty set or set B is empty. Because in any one of the set, it becomes a null set. Then there is no elements to pair with the other set. So obviously A cross B will become an empty set. And if A is equal to B, then A cross B is nothing but A square. So A square is nothing but we are pairing A cross A. Now, the same thing can be defined with respect to the three sets, that is the Cartesian product of three sets where the elements will be in the form of triplets, A, B, C. We call A, B as an ordered pair. So this is an ordered pair, whereas this is triplet. Here first element belongs to first set, second element belongs to the second set, and the third element belongs to the third set. So clearly you can see A belongs to A, B belongs to B, and C belongs to C. Now we have a problem here. If A is equal to A, B, C and B is equal to C, D, then find A cross B, B cross A cross A, B cross B. So A cross B, first one we need to pair A cross B. So when I say A cross B, I am pairing A, B, C with C, D. So let me pair here A, C, A, D. Next we will pair with another element B, C, B, D. And the other element C, C and C, D. Again, we will enclose this with flower bracket because Cartesian product is also a set of ordered pairs. Now, we can also count the number of ordered pairs or the number of elements inside the Cartesian product. How? We have number of elements of A as 3, number of elements of B as 2. So, 3 2s are. So, 3 into 2 is equal to 6. So, therefore, there will be 6 elements inside A cross B. Now, let's go for the second one, that is B cross A. That means we are pairing B with A, C, D cross A, B, C. So how many number of elements should be there in B cross A? 2 into 3, 6. So let's check this. C, A, C, B, C, C. Then we'll pair with D, D, A, D, B, D, C. So clearly this is B cross A. Observe here, none of the ordered pairs in A cross B is equal to B cross A. That is A, C is not equal to C, A. They are completely different. So clearly A cross B cannot be equal to B cross A. So Cartesian product is not commutative. Now let's check for A cross A and B cross B. A cross A. So that means I am pairing A with A, B, C cross A, B, C. So how many elements should be there in A cross A? 3 into 3, 9 elements. So let's write all those 9 elements. So first A, B, A, C. Next pair with B, B, A, B, B, C. Next pair with C, C, A, C, B, C, C. So clearly you can see 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 elements in the Cartesian product A cross A. Now the last one, B cross B. So set B is C, D, C, D. So here let's pair C, 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 D, D, C, D, D. So 4 elements. So 2 into 2 is equal to 4 elements in B cross B. Now when I am defining A cross A and B cross B, we know the definition of the Cartesian product. If we have an ordered pair A, B in the Cartesian product A cross B, that means A belongs to the first set and B belongs to the second set. But here in the A cross A and B cross B element, both element A and as well as the second element belongs to the same set, because we are pairing the elements of the same set. That is why we will define A cross A as A square and B cross B as B square. Next question. A is equal to A comma B comma C, B is equal to D and C is equal to E. Then verify A cross B minus C is equal to A cross B minus A cross C. Now first let us check the left hand side. First we will find what is B minus C. So when I say B minus C, it is set D minus set E. So B minus C means from the concept of sets, it is the only elements in B, not in C. So clearly D is the element which is only in B, not in C. Now we need to pair D with A. So A cross B minus C. So what is set A? A comma B comma C cross D. And when I pair this, we will get the ordered pairs A comma D, B comma D, C comma D. So this is our A cross B minus C. So let me take this as equation 1. Now let's move for A cross B. Now A cross B means, so we are pairing A and B. So we will get A comma D, B comma D, C comma D. Now let's go for A cross C. A cross C means I am pairing A with C. So we have A comma E, B comma E, C comma E. Now let's check A cross B minus A cross C. So A cross B minus A cross C means elements only in A cross B, not in A cross C. What are the elements only in A cross B? All the 3 elements, because they are not repeated in A cross C. So obviously that is A comma D, B comma D and C comma D. Let me take this as equation 2. Now observe equation 1 and 2. So we have the ordered pairs A comma D, B comma D, C comma D in both the sets. So clearly we can conclude A cross B minus C is equal to A cross B minus A cross C. Next question. If A cross B is equal to A comma 1, A comma 2, A comma 3, B comma 1, B comma 2, B comma E, find A and B here. So now here when we are defining A cross B here, so all the first elements belongs to the first set. So that means A, B belongs to the first set and second elements belongs to the second set. So therefore 1, 2, 3 belongs to the second set. If 2x comma x plus y is equal to 8 comma 4, find x and y. So we know that 2 ordered pairs are equal if the first elements are equal and the second elements are equal. So using that condition, we will get 2x is equal to 8 and x plus y is equal to 4. So from this equation, we will get x is equal to 4. So let me put x is equal to 4 here. So we get 4 plus y is equal to 4 or y is equal to 0. So therefore, the value of x is 4 and the value of y is 0. Next, we come across the concept relations. So relations are nothing but the subsets of a Cartesian product. That means the elements of A and B will be connected with some relation between them. Let A and B are the sets and the relation from A to B is a subset of the Cartesian product and it is denoted as R as a subset of A cross B. Now let me take an example in the set A of natural numbers. Now define a relation from set A to set A. That means set of natural number to set of natural number in such a way that y is equal to x square. So let me consider a set n. So which contains 1, 2, 3, 4, 5, 6, 7, 8, etc. And I am defining the relation from 1 to n again. 1, 2, 3, 4, 5, 6, 7, 8, etc. Now consider here we have taken a relation in the form of y is equal to x square. So if you substitute the value as 1, so 1 is 1 square, it is connected to 1. 2 is 4. Similarly, if we go 3, it is some 9. So 4 is connected to 16. So the ordered pairs here will be in the form of 1, 1, 2, 4, 3, 9, etc. So this is the relation set. But when I consider the Cartesian product of these two sets, so A cross A or N cross N will be in the form of 1, 1, 1, 2, 1, 3 until the last number. Similarly, it goes on 2, 1, 2, 2, 2, 3, 2, 4 and it goes on until infinite number of values. That means all the elements in set N is paired with the set N. So we will be having an infinite number of ordered pairs in the Cartesian product N cross N. But when I take the relation and when I define the relation, we will be having the only elements which is 1, 1, 2, 4, 3, 9, 4, 16, etc. All these elements are in the Cartesian product and also in the relation. So that's why we always say that the relation is a subset of Cartesian product A cross B, where elements are defined under certain condition or certain relation. So A cross B will form a universal set for a relation. A relation R from A to A is a subset of A cross A. If the set A has M elements, set B has N elements, then A cross B has Mn elements. We have already verified that. Suppose if set A contains 2 elements, set B contains 3 elements, then A cross B will have 6 elements, that is 2 into 3. Now, we know that if Mn is the number of elements in the Cartesian product, then obviously number of subsets will be in the form of 2 to the power Mn. So we have already studied under the sets that if set contains n elements, then 2 power n represents the number of subsets of the given set. Similarly, if a Cartesian product has Mn elements, then the number of subsets that Cartesian product contains is 2 power Mn. Remember, number of subset is also nothing but number of relation, because relation is a subset of a Cartesian product. If there exist 2 power Mn relations from A to B, then there also exists 2 power relation from B to A. If R is a relation from A to B and x, y belongs to R, we always write it in the form of x, R, y. So x, R, y means x, y belongs to R. That means the ordered pair belongs to the relation set. Domain and range of a relation. Let A and B be two non-empty sets and R be a relation from A to B, then R is a subset of the Cartesian product A cross B. The domain of R is defined as the collection of all the first elements of the ordered pairs. The range is defined as the second of all the second elements of ordered pair A, B. Now, for instance, I have taken an example of y is equal to x square in the set of natural number. If I write the relation set, then it will be like 1, 1, 2, 4, 3, 9, 4, 16, etc. Now the domain is nothing but all the first element in the ordered pairs. So what are the first element in the ordered pairs here? 1, 2, 3, 4, etc. So this forms the domain. Range is nothing but the second elements in the ordered pairs of the relation set. So here it is 1, 4, 9, 16, etc. So this is the domain and range of the given relation. Next, if A is equal to 1, 2, 3, 4, 5 and B is equal to 1, 2, 3, 4 and R is a relation from A to B defined by x, y is equal to 2x plus 1, find R. So we need to take y is equal to 2x plus 1 form and R is a relation from A to B. So find R. So domain is always taken from the set A. That means the value of x must be taken from the set A and range we should identify in set B. So let me take here, this is set A which contains 1, 2, 3, 4, 5 and this is set B which contains 1, 2, 3, 4. We should always take the domain element from the set A. So we have a relation y is equal to 2x plus 1. So let me take x is equal to 1 here. So if I put 1 here, then it is 2 into 1 plus 1 which is equal to 3. So my first ordered pair in the relation set is 1, 3. So that means 1 is paired with 3. Next we will take x is equal to 2. So we have 2 into 2 plus 1 which is equal to 4 plus 1 which is 5. So we don't have 5 in B. So the only set which is possible here is 1, 3. So that means we can find a relation from A to B where my first element should be in the first set and second element should be in the second set. But for x is equal to 2, we are getting the ordered pair 2, 5 which cannot be inside the relation because 5 is not in the second set. Now what is the range of this and domain of this relation? So domain will be equal to 1 and range is equal to 3. Next, if A is equal to 2, 3 and B is equal to 3, 4, find the number of relations that can be defined from A to B. First find number of elements in A cross B. So number of elements in A cross B, that is the cardinality of A cross B is 2 into 2 which is equal to 4. So therefore, number of relations is nothing but the number of subsets. So relation means subsets. So relations is nothing but subsets of A cross B. So which is nothing but 2 power 4 that is equal to 16. Next question. Find the domain and range of the following relation. So they have given the relation set here. Let's write the domain and the range. So domain is the first element in the ordered pairs. So 1, 1. So the only domain element is 1 and range. So range is here 2, 3, 4, 5, 6, 7. So this is the range. Second question, R is equal to x, y is equal to x cube. X is a positive prime number less than 10. So the condition of x is less than 10 and that should be prime number. Then what are the values of x I can take here? So I can take 2, 3, 5 and 7. These are the only prime numbers which is less than 10. Now substitute the value of x as 2, 3, 5, 7 and we will write the relation set here. So the very first element is 2, 8 because x is 2, y is written as x cube. So 2 cube is 8. Next 3 cube 27. Next ordered pair is 5 and 5 cube is 125. Next ordered pair is 7 which is equal to 343. So now the relation set is 2, 8, 3, 27, 5, 125 and 7, 343. Now let's write the domain of this set. So domain of the relation here is 2, 3, 5, 7 and range. So range is equal to 8, 27, 125, 343. So this is how we define the relation of the Cartesian product A cross B and how to write the domain and range of the given set. That means domain is nothing but the set of all first elements in the relation set and range is nothing but the set of all second elements in the relation set. I'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.